Hello, everyone. Hello, hello, hello. Hello, Anas. Hello, Bongamusa. Hello, Raul. Hope you're all doing well today. This is week 5 of World Quant. Yes, if I've calculated correctly. So week 5. Hello, Martha. My plan is that I'm not going to start talking about the DW Mini project until more or less the end of this week, early next week. Right, you guys should go through the Pandas material before we talk about the DW Mini project. But we can talk about we finish with the PW Mini project. I remember we started on the question 4 on Thursday. Hello, Emil. Hello, Nafisat. Hello, Adekunye. Hello, Roxnell from Benin. I like that name, Roxnell. I've not seen that name before. Hello, Osaluse. I hope I'm pronouncing your name correctly. Hello, Priscilla. So let's see here. Items by region. So we have this prescription data. So let's review. We have this prescription data from the NHS. So in this scripts list is a list of dictionaries. These are individual prescriptions for individual people. So, someone who visited this doctor's practice was prescribed this drug, and the items right here is basically they got like that item and they got a refill. So this is my understanding of this items. I thought we had here we go. Yeah, number of refills. All right, items is number of refills. And we had information about cost and this is like the actual cost. This right here is what it was sold for. Our net ingredient cost. Sorry, not what it was sold for. This was the the actual cost, total cost, including containers, fees, and discounts, net ingredients cost, and so on. So question 1, we calculated some summary statistics about these numeric fields. Question 2, we wanted to know what was the most common item. And the most common item, as I pointed out to someone in the message board today, we're not looking at the number of times some drug appeared in the number of dictionaries. No, we want to know the number of, we want to sum up these items for each individual drug. That's what we did in question 2. So most common item. Question 3 was, in question 2 we had this more generic group by field. We wanted to apply, again, as I said here, data is a list of dictionaries, fields is a tuple of dictionary keys, which should exist in each dictionary in this list of dictionaries, and this will return a list of dictionaries. Sorry, oh, hang on, I should have said here this would be a dictionary of list. I don't know why I wrote returns a list of dictionaries. This returns a dictionary of lists. Right, we create a dictionary right here. The keys are tuples, and the values are a list. Each key has a list associated with it. Maybe I should say this returns a dictionary of list of dictionaries. That's not confusing at all. A dictionary, a list of dictionaries, right? So because this groups right here is a dictionary, again, the key is a tuple, the value is a list. Each element of each individual list is itself a dictionary. Right? Half the battle here is figuring out or remembering what our data types are. We use this method, so again, we wanted to find the total items prescribed in each postal code representing the results as a list of tuples. So postcode total items prescribed. We had this little wrinkle. Some practices have multiple postal codes associated with them. Use the alphabetically first postal code. So that was where we had this practice postal dictionary, where this is again a dictionary. The keys in the dictionary are practice codes. The values in the dictionary are postal codes. And then once we have this alphabetically first postal code, then we join our data together basically by adding a postcode to each of our prescription items. Right, so now we have our dictionary, which corresponds to a single prescription, has a postcode associated with it. And then once we have this list of dictionaries, well, we could do our group by field method to group by postcode, and then we sum up the items for everything in the same postcode. So we sum up these items right here. And then we get this list of postcodes and total number of items that were prescribed in the postcode. Again, if there's any questions, well, jump in here. Question 4, we wanted to, it said, we'll combine techniques we developed to answer a more complex question. So find the most commonly dispensed item in each postal code, representing the results as a list of tuples, so postcode, BNF name, and amount dispensed as a proportion of the total. Right, within this postcode, there were 5,000 items dispensed in total over all BNF names. Oh, this BNF name was dispensed the most. That was dispensed 250 times. In that postcode, well, I want that BNF name that was dispensed the most, and the amount dispensed as a proportion of the total. So if it was dispensed 250 times in total out of 5,000, well, right, I get what, that's like 2% or something like that. Whatever that number happens to be, right, as a proportion. So it said we will use the joined variable as before, where we've chosen the alphabetically first postal code. There's a suggestion here some postal codes will have multiple BNF names with the same number of items prescribed for the maximum. In this case, we'll take the alphabetically first BNF name. I'm not sure that's actually true, but it's not hard to deal with taking the alphabetically first BNF name. So, as we said, we guide you through one way to solve this problem. So, and we did this on Thursday, we did this first step, right? The first step is to calculate the total items for each postcode and BNF name pair. Right, because this is part of what I want to be able to find. I want to be able to say, well, for this postcode, what was the item that was prescribed the most in that postcode? So we group our data by this pair, postcode and BNF name. And so, right, I'm not going to print out this big dictionary because I will probably crash my kernel, but I selected a postcode and a BNF name combination which I knew would exist. So remember, my dictionary keys are tuples of values. So for this postcode and this drug name, well, I had this list of dictionaries that was prescribed, right? And I want to take 1 plus 9 plus 7 plus 2 and, get a total. So I want to, have some way of representing this data as a postcode, a BNF name, and the total items where we've summed all these items. Now, I want to store this information, and I need at some point, right, I need to be able to compute the total number of items that were prescribed within a postcode, because I want to get an amount dispensed as a proportion of the total. That's the total out of that postcode. Right, so at the moment I have, I could take my groups and I could compute information. I sum all the items, And for example, this would give me this, what? Again, 1 plus 9 is 10, 7, 12. I get 19. 19 items were prescribed for this postcode and this BNF name combination. Now, I want to use my group by field, my group by, methods, group by field method, again, to help me compute the total items prescribed within each postcode. My group by field is looking for a list of dictionaries, so I have to construct a list of dictionaries to feed to my group by field method again. This is why I'm creating a list of dictionaries right here. Right, this key right here in my group by post BNF is, again, a tuple. My variable k looks something like this tuple here. So I have the postcode and a BNF name for my key, my variable k. I sum up the items, so remember V is going to be a list of dictionaries. I can iterate over these dictionaries, extract the number of items, and then compute the sum. Now, as I said, I'm going to create a list of dictionaries because I want to feed this information in again into my group by field method, which is looking for a list of dictionaries. So this is why I'm creating a dictionary right here and appending it to my list. My dictionary will have 3 things in it: one, the postcode, the BMF name, and the total number of items prescribed for that postcode BNF name combination. Right, so this is total items by post BNF. So postal code and BNF combination, right? So again, for this postcode and this BNF name, there were 7 of those prescribed. And remember, that's summing up the values and the items in each dictionary here. Now I want to do 2 things. Well, here we might have said several things, right? What do I want to do? Unable to load your PW notebook. I don't know why. Did you print out a lot of information in your notebook? That may be a problem. If you printed out a lot of information, you may have a problem loading the notebook. You may have to do one of 2 things. You may have to edit the notebook as a text file and remove the big output. Or you may need to, you may need to get a new copy of the notebook. I said you can do one of 2 things. One is you could edit your notebook as a text file. I'll go here to terminal, because like, for example, a Jupyter notebook is stored as a JSON file. This is my Jupyter Notebook for my in mini project. This is just a JSON file. But of course, you need to be a little bit careful when you edit JSON to keep the format. Right? Find cells where there's lots of output and probably delete those cells. Or you could use the update scripts module, or sorry, update scripts, sorry. You could use the update modules script to get a new copy of the data wrangling folder with which would then have a new copy of PW in it. Right, you'd say update modules.sh data wrangling. This would download a new copy of your data wrangling folder into a directory called data wrangling.new. And you'd have a fresh copy of your PW mini project in there. Yeah, if you have a very, very big Jupyter Notebook, you may not be able to open it up. Why might you have a big Jupyter Notebook? Well, if you printed out a very big data structure, like if you print out a huge list of dictionaries, you may not be able to load that notebook. So either you have to edit the JSON file, but edit the JSON file as text using a text editor, PW, right, I might need to delete some cells. Make sure you delete, whole cells, right, in between one opening curly brace and the closing curly brace to delete a big cell so that you maintain a proper JSON format. Otherwise, you're going to have to re-download a copy of the PW Mini project and go from there. So, like I said, here we have a list of dictionaries, postcode, BNF name, total items. Now I want to do a few things, right? I want to find within each postcode, I want to find the BNF name that has the maximum value of total items. Right, and that's the item that I want to, kind of hold on to. I want to know which item was prescribed the most within each postcode. But I also want to group things by postcode and sum up the total items prescribed in that postcode, right? Because I need to compute this proportion of items. So, am I making sense? So I want to use my group by field method again. I'm going to group my data by postcode. Come on. So I want to find the item within the postcode that was prescribed the most, and I want to compute a proportion. So right, I have like So the idea. So I have the postcode CV7 for AL, whatever. I have drug, A was prescribed 5 times, and the same in the same postcode CV7 for AL, drug B was prescribed 10 times, same postcode, drug C was prescribed 7 times, etc. I want to find which drug was prescribed the most within the postcode. So I want to find this item, this assuming this is prescribed the most, but I also want to compute the sum of all these numbers, because I want 10 divided by the sum here of all these numbers to compute a proportion. So I can do my group by field, take my total items by post, group by the postcode. I said there should be 118 groups, i.e. 118 different postcodes. Here's one example. So all the postcodes here are the same, all the BNF names here should be different. I want to find the item that was prescribed the most. Oh, here's a 97. Oh, is that the most? I don't know. I don't want to search through all these things individually, of course. I want to write a method that will do the following. And here we write this as 2 things. I'm probably going to combine these things together. I want to calculate the ratio inside here. Right, I want to find the sum of total items for all BNF names within each postcode. So the sum of all items for all BNF names in a postcode, which drug has the most? The BNF name that had the most total items. And I'm going to stick in here, I want to compute the proportion of the item with most total items. So consider the best data structure to represent the results. So the idea here again is I have a list of dictionaries, right? My grouped postcode is giving me it's giving me, I keep on saying things, slightly wrong. The group postcode is giving me a dictionary of lists. The list itself is a list of dictionaries. So group postcode is a dictionary. The value associated with the key is a list. The items in that list are themselves dictionaries. So Yeah, so I said I want to compute. I want to. I'm going to take a key. Let me see if I'm looking at the right information here. Yeah, all right. Find the max BNF. All right. My notes must be looking at some other version of this file. So this is why I'm a little bit. Yeah, so I want to return a dictionary or tuple something. I'm probably going to return a tuple containing a postcode, the BMF name with the most total items, and the proportion of the item with the most total items. So the idea here, so let's add some information. Key is going to be a postcode. Data is a list of dictionaries for that particular postcode. What I'm going to do here, right, I want to find, so total prescribed is the sum of D, what does my dictionary look like? Total items for D and data. I want to, so the argmax. What do I mean by argmax? This is going to be essentially like the dictionary that has the maximum amount for total items in this dictionary. So I want to think of sorting my list. I have a list of dictionaries. I want to sort my list by pulling out the total items. And I want to sort so I have the maximum total items. So I'm going to take my list, sort my list of data, and this is going to give me a and I want to pull the first element from this sorted list. So I'm taking the first element from this sorted list. So my BNF name is argmax of my BNF name. My proportion is equal to what? My argmax of total items divided by total prescribed. I'm going to return a tuple, which will have my key, which is a postcode, my BNF name, and my proportion right here. Let's see, so if I say, let's take this postal code. If I say find max BNF with this postal code and my grouped postcode data, dictionary, there's my dictionary here. So I get a postcode, a drug name, and a percentage of total. Right, because the idea here is, again, I have this dictionary. I want to sort this dictionary, and the way I'm going to sort this is to look at the total items, and I'm going to sort it in reverse order because I want the maximum first. Oops. Sorry, let's scroll up top. Right, total items. I want the item with maximum total items. Now, there's a little wrinkle that we may have to deal with. Oh, no. Where did I read that? Total items, total. Right, some postal codes will have multiple BNF names with the same number of items prescribed for the maximum. This case will take the alphabetically first BNF name. Now, it becomes a bit tricky to, right, I want the item that was prescribed the most. And if there's a tie, I want it alphabetically first here. So I'm going to do the following thing. I'm going to remove this reverse. But in my key right here, I'm going to put a minus sign in front. Right? I'm negating the value of total items. So when I sort these dictionaries, I'm treating this as minus 1074. Because what I want to do, so let me make an example right here. So suppose I have a dictionary, so I have BNF name is drug A, and total items is 12. And I have BNF name is drug B, drug B, total items is 10. ENF name, oops. Let's try. Right. I should have thought out my example a bit more. If I sort I get, if I sort with minus the value of the total items, I get this dictionary coming out first with total items 12, and this one coming out with total items 12. I would want to make sure that I pick the alphabetically first name. If I change this drug C to be C, I want to make sure to pick C over drug A. I could do this by creating a tuple here. Remember, if we sort by tuples, we sort first on the first component of the tuple, and if there's a tie on the first component in the tuple, we go to the second element of the tuple to break ties. Right, so if total items is tied on 12, we go to the second element of the tuple to break ties. C comes before, capital C comes before capital D, and I get the item with the first, alphabetically first name. Right, so it's kind of understanding how we want to sort our list. Remember, overall, this is a list. Happens to be a list of dictionaries, but it's a list. I could sort a list by passing it to the sorted function, and I can tell Python how I want to sort the list by providing a key, which is a function which can tell Python how I want to sort the list. I'm negating the number in front of total items, right? So I'm treating 12 as minus 12 when I do the sort. It still comes out as 12, but I'm treating the 12 as minus 12. So this will sort the dictionary so that largest total items will come out first. If there's any ties, I want to break ties in favor of the alphabetically first drug name. I could break ties by creating a tuple in my sorted function. So I want to treat the total items as a negative number so that larger numbers will come out first. And again, if I break ties, I want to break ties by alphabetically first. I could do that by supplying a second element to this tuple, which is the name of the drug. So I could do that. I can do that here as well, right? And I could do this here in my function that I have below. Oh dear, let's make this smaller. Right, I could supply a key, so I could say minus X total items and XBNF name. but I want to then remove my reverse is true. So I could iterate over my grouped postcode data. So I could iterate over grouped, my group postcode data. So I could say I want, sorry for the scrolling, I can't remember the names of these functions. So I want find, let's make a list. I want find max BNF of K0 and V for K, V in grouped postcode dot items. Most item data by post. I should have one tuple for each postcode. I get a postcode, a drug that was dispensed the most, and a proportion of that drug that was dispensed within that postcode. How many of these items do I have? Length of most item data by post. I have 118. I've actually calculated the ratio already. I need to sort alphabetically by the postcode. I already have a list of tuples, but I need the first 100 tuples. So items by region is sorted most item data by post. I take only the first 100 items. That doesn't seem. Oh, sorry. I forgot my colon. Colon 100. All right, I want the first 100 items, not the 100th item. So there's probably many questions here, I'm guessing. Right, I just want to keep in mind again what we have. So our grouped postcode data is a dictionary. The keys in dictionaries are a postcode stored as a tuple with one item. The value associated with a particular key is a list. Happens to be a list of dictionaries. So I want to iterate over this grouped postcode data, right? Because again, I have a postcode and I have a list of dictionaries. I want to do basically two things. One, I want to find the dictionary. In particular, I want to find the BNF name and the amount of total items where the amount of total items is largest in this collection of dictionaries. I want to know which of these small dictionaries has the largest value for total items. I want to know what is that value of total items, and I want to know the value of the BNF name that goes along with that total. And then I would have two pieces of information. I want, well, three pieces, 2.5, however you want to say it. I'd have a postcode, I'd have a drug name, I'd have the total items for that particular drug. Now what I want to do is I want to sum up this value and this value and this value and so on for every dictionary that's in this list. And we could write a function that will do this. Right, as it says here, return a dictionary. So return a dictionary or tuple. I went for a tuple containing the following: a postcode, the BNF name with the most total items, and the proportion of the item with the most total items. So again, the key is a postcode. The data is a list of dictionaries for that postcode. So again, I want to take the total items for each dictionary and sum up those total items. That gives me the denominator of my fraction that I want to compute. Right? This is my denominator. This is my denominator of the proportion that I want to compute. I want to find the item that has been prescribed the most. So I'm going to sort my list of dictionaries, but it's a list. I'm going to sort my list. I'm telling Python how I want to sort my list. I want to negate total items, right? I want to treat the value of total items as a negative number, because then this will put the items that have been prescribed the most at the beginning of my list. If there are any ties, I want to select the first item alphabetically. I could do that by, telling Python to sort according to this tuple. So again, negate total items, so this will put the items that had the largest values first. If there's a tie, I want to break the tie by considering the alphabetically first BNF name. So I sort my list of dictionaries and I take the first item, which is what this bracket 0 right here is doing. Take the first item. So this argmax right here is going to be a single dictionary. It's going to be one of these, it's going to be, in this case, it'll be, for this postcode, it'll be this dictionary. Then I get the BNF name as this dictionary key. I didn't have to do this, but I was just trying to be a bit more clear, right? Get the BNF name. And this proportion, the numerator of my proportion is the number of items that have been prescribed for that particular drug. And I've computed the denominator previously. And then I just return this tuple. My key is my postcode. My BNF name is what I've got before. My proportion is what I had before, right? This is trying this out on one postcode with the corresponding list of dictionaries. Then I could create a list of tuples by iterating over my items in my dictionary here. Right, so K is a tuple with one item in it, namely the postcode. V is the list of dictionaries that correspond to that postcode. So this will give me a list of tuples. I'm nearly done. I have to sort this list of tuples by postcode and take only the first 100 values. There's 118. I need only the first 100 values. So I sort my tuples. Again, sorting tuples, Python will sort by the first element in the tuple. If there's ties, which there shouldn't be, because these postcodes are unique because of the way we constructed the groups, it would go to the second element in the tuple, but there won't be ties, so we sort, keep the first 100 items in our sorted list of tuples. Lots of omeprazole capsules. And I submit my list of 100 items to the grader. And in the next mini project, which I'm not going to start until the end of the week, I may not even start it until next week, but we look a bit more into, the prescription of opioids by the NHS. Lots of omeprazole capsules, again, which is some sort of opioid, I believe. Are there any questions on what I've done here? I know it's kind of a lot to take in. But again, this is all list comprehensions, dictionary comprehensions, using the methods to sort data in Python, sort the data to get it in the format that we want it. Right, and part of programming in Python, part of becoming a better programmer in Python is to understand how to write list comprehensions and dictionary comprehensions and use these built-in methods to manipulate this data to get it in the format that we want. So again, any questions on what I've done here? Right, the office hours are available, for you to go back and watch again. I've tried to describe what I'm doing, hopefully in a way which is relatively clear. I know that understanding the sort method and how we can specify various ways to sort data in Python, especially when that data is tuples or something more complicated, right? I have a list of dictionaries. I'm having Python sort a list of dictionaries for me. And I'm telling Python how I want Python to treat that list of dictionaries to perform this sort. And so it's important to understand the use of this key parameter in Python, which I could use to specify how I want Python to sort a list. So I'm going to leave things there for today, and I will see you all tomorrow. So have a good night, and I'll see you tomorrow.